Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome back to the 12-week course on circular economy for sustainable buildings. Today we will look at the topic which we have been repeating several times in the past few classes, and that is design for adaptability. So what is adaptability? The ability of any space to be changed or modified for the use beyond the one that is originally designed for. And an example of this that I always reiterate, and I have done that in the past in this course, is also, what did we do during COVID times? Nobody expected the concept of work from home, study from home at all. The house was designed as a place to live. We had the living room, dining room, bedroom. Suddenly, we had to convert these into workspaces in such a way that we look professional also. Meaning to say, an IT professional, when he sits and works, he cannot have his cook passing behind him, or the sound of a crow near his window. He cannot have that because it was deemed to sound very unprofessional. So the entire concept of spaces changed, and we started looking at how we can make our existing residence adaptable to various other functions, such as gym. We had young men, boys doing their workouts inside the house. There was so much shoot up of buying gym equipments, dumbbells and things like that. So a great example, or COVID was a great leveler to make us understand social changes. And then adaptable. So what I am trying to say is, now when we design houses or when we design buildings, we need to design them for changing social changes. We need to project and predict. For example, the way a 2-year kid interacts with society is different from when that kid grows up to be a 10-year-old child, and the way the child again has social interaction when he is 17-18 years old, or 26 years old, and 40 years old, and 60 years old. The house is the same, but his social interactions change, and the house should be able to accommodate these changes. Also, after a particular time, when people age, it's very difficult to lead the routine life in the same manner as it was designed when they were young. So the house cannot be immediately demolished and a new house built for the elderly who are actually owners of the same house. The house should be able to absorb and adapt to these changes also. Also, a house should be able to adapt to changing climate. So, this is a stark case, especially when you look at composite climate. Suddenly, it is like in summers, it is 45, 48, 50 degrees centigrade sometimes. And then the winters are very cool. You get like 2 degrees centigrade or even sub-zero temperatures. So, the house should be able to adapt to both these scenarios. And as I always said, working from home, in fact, some of the offices have work from home concept only. There is no going to office concept. So the house should be able to adapt to this also, and it should also be able to adapt to variable household sizes. When somebody starts building a house at the age of 30, they could probably be a husband, wife with a small kid. maybe a 6-month or a 8-month-old kid. Slowly, it becomes a family of 4 people. Slowly, aging parents or in-laws move in. And so, see, you look at the size of the household, the house remains same, but the household is changing and increasing. And the trend just doesn't continue like that. Over a period of time, no, children become no, adults, and they move out of the house, and then again it's just 2 people living in the house. Throughout this process, the house should be able to adapt to the change. That is what I mean by adaptability. So, an adaptable design should accommodate lifestyle changes without the need to either demolish or even substantially modify the existing structure and services. As an example, as the case to this point, if we are designing for a house where the inhabitants are bound to be aging, then what are the considerations we should give? We should look at giving wider doorways, because once they move into becoming little immobile, they may need a walking stick or they may need a wheelchair, for which the doorway should be able to adapt. Then there should be wheelchair accommodation, a facility where people can move within the house freely on a wheelchair. Then accommodation for lift, because sometimes if a person lives on first floor, when they are young they don't need a lift, but when they become senior citizens, sometimes they may need lift. Or even if you look at a small clinic, when it is a clinic and it begins to grow and they start moving to first floor or second floor, they need lifts to take their patients to higher floors. So it should be able to accommodate a lift. If it's for the aging person, then access to latches. They no longer can actually stretch their hands way too far and operate the latches. So latches should be accessible to the senior and the elderly. And same is with cupboard heights and cupboard handles also. Also, as the home starts to shrink, as the household starts to shrink, we should be able to downsize the spaces and make flexible room functions. Now we will come to another concept also, which is disassembly of buildings. So I'll go back and forth on these two terms. So a disassembly friendly design is a very important part of circular construction. In fact, that's one of the first prerequisite for circular construction, in which waste can be minimized and it can be optimally recycled. Now, if buildings were deconstructed instead of demolished, the consumption of construction material can be reduced, and because of that, the depletion of primary resources will get reduced, because of which environmental hazards will get reduced, and also climate change will slow down dramatically. Now, why should we aim for complete recovery of building materials? And how can we achieve this complete recovery of building materials? That can happen by, first is documentation of materials and the method of deconstruction. Second is, see, when I say documentation of materials and methods of deconstruction, it could even be probably that you actually have to start your designing and drafting for deconstruction and then give a plan for how the building would actually look when it is put together. So you are actually doing reverse of what we are doing now. Today we design, we build, and then once the use is over, we demolish. But here what I am saying is, you first look at how you are going to deconstruct a building and then look at how you put it together to achieve the design that you want. Second is to select recyclable and renewable materials based on the precautionary principle, that you don't have to waste too much of it when you deconstruct, where no, you are not causing too much of environmental damage and hazard and so on. Very, very important. Third is design connections to be completely accessible. So you can't have a element in a building and then not know how to dismantle it. You should know the joints and they should be clearly visible, and that is when it can be dismantled. Fourth is minimize or eliminate toxic and insoluble connections. So, the what that basically means is components should be dismantled easily without applying anything that could be toxic or anything that could be so rigid that it is difficult or impossible to dismantle. Therefore, use bolts, screws and nailed connections so that it can be easily dismantled, it can be visible and it will be strong. Sixth is separate the mechanical, electrical and plumbing systems so that you don't have to segregate anything. It's all already segregated and installed in the building. Seventh is design for the workforce and the work of separation. So, have a separate plan for dismantling. Eighth is have very simple structures and form which is, it's obvious how you can dismantle it. Ninth is interchangeability and therefore modularity. Swapping modules should not really change much. And 10th is safe dismantling. While dismantling, it should not cause hazard to the human being. Now, what all can design for disassembly lead to? First is it can make designing very flexible for multi-use. More people can use it. Second is it should be retrofittable. Any panel or any board is damaged, or say for example any tile is damaged, you don't have to remove the entire flooring, you can replace only that tile. That is retrofittability. And then deconstruction of the entire building should happen easily. Now, during the planning stage of the building, it should already be clarified or documented how materials can be recycled and reused. I will say even committed on how we can recycle and reuse material. And in this case, life cycle analysis can be very useful. Here you see example of a building which is under disassembly or rather assembly. So, very easily or you can clearly make out the panels or the components, but at the same time you should know how they are fixed, and all that I told you in the previous slide is applicable here. It has scope for expansion, it has scope for reduction, it has scope for getting dismantled, or scope for easy and fast construction and so on. All of this is applicable here. Now, if we look at adaptability, why should we go for adaptability? What is the aim? So, the main aim of design for adaptability is that we should be able to lengthen the lifespan of the building. So, the lifespan of the building gets lengthened because we will be able to adapt the space with very minimal disruption. What are the advantages of adaptable design? So, first, advantage of adaptable design is it can lengthen the building's lifespan. You don't near you don't necessarily have to demolish a building no, to suit the future requirement or use. Second is you can preserve the building's cultural value, then the sentiment, etc. Because you are not pulling down the entire building, you will live in the same building. Third is you can preserve the economic value because demolition and building can be a very expensive exercise. An example or case to the point, especially concerning point number 2, is adaptive reuse of historic buildings. In this context, let us look at a couple of case studies. So, adaptive reuse of historic buildings. For example, old vernacular mansions getting converted into holiday homes. For example, the Havelis of Gujarat, Rajasthan, or even the houses of Chettinad, which undergo adaptive reuse. Now, one of the easiest ways to consider adaptability is to go for adaptive reuse. Let's look at the example of adaptive reuse of Alembic heritage development at Vadodara, which got converted from an industry to a cultural center, because Alembic is a very historic pharma related company, and it has a big history also. So this Alembic heritage development at Vadodara got converted from industry to cultural center, and in this they hosted the Alembic Museum, art studio, exhibition and display spaces here. So this is the whole site, and we would particularly be talking only of these things. It's located in Vadodara in India, and this project was done by architect Karan Grover and Associate. This Alembic industry has nearly 92 acres of industrial land, that too in the center of Baroda or Vadodara. And this is more than a century old. That is, this was established in 1907, ages back, and it has been growing ever since. So, which means it's an important piece of history, architecturally as well as in the history of industries. Now, they have been producing various things, including pharma, where they produce tinctures or spirits or ethyl chloride, etc. And then the Iyer glassware. So, that is also manufactured by them. But what happened is, over a span of 110 years, many of the buildings became useless because of the changing nature of industrial production technology. Now, this made the clients to take a call. Now, they could have demolished it, or they can call for a new master plan for the entire campus, which will sort of convert it into a corporate hub, including having few office buildings, few manufacturing units, retail units, as well as recreational facilities. Because of the technological advancement, this campus, it started housing a lot of obsolete machinery, and there was a need to look at the machinery in a sensitive manner, because it shows the chronological order of growth of Alembic industry over a period of time. And this brief led the clients to want a museum within this industry campus to display the whole history of the industry. So, this master plan marks the building, which is shown highlight as I have shown it, as a recreational block which would have museum, artist studio, exhibition area in the first phase of implementation. So, this Alembic factory, which is located along a main railway line in the city of Baroda. Because those days, that's how it was. The raw materials would come from the railways and the industry would be close to the railway track. So, in its 112th year of existence, more than a century old of existence, the first ever Alembic industrial building has seen many interventions, many kind of changes. So, similar to many old factory buildings, this building got altered over a period of time, and starting from manufacture of penicillin to alcohol to pharma to glassware, all this had to be displayed in the museum. So, this space, which was meant to serve as a museum, art studio, display, exhibition space, etc., also had certain other facilities to be incorporated, which is library, audio visual room, and also a cafe. So, it was quite a challenging project, and the no, the architectural purpose was to look at this as more a sculpture to maintain the true quality of the building. When you look at the materials or the spatial quality, the language of its architecture, the morphology of spaces. So, the only new architectural elements that were introduced here were partition walls in between studio spaces. So, the existing building is characterized by arches which have been blocked. So, they opened up as many arches of this structure, and they are in the process of finishing this with some material. So, this is the view of the inside, which has been converted into a gallery and a museum. So, what they did was they tried to use sand blasting or water jet treatment to remove all the plaster from the brick and the moss that was found in many areas, because the plaster was anyways peeling and falling off, and it would have continued it that way. So, they wanted to remove the damaged plaster. Then another major design element was the roof. As you see, there are a few structural details that are very interesting. The trusses are riveted as against being welded, and the detail of the riveted truss is that the riveting is very finely done. Many of the trusses were actually in very good condition, and only few of these trusses needed some strengthening. The outside of the roof material was made up of mangalore tiles. So, these terracotta tiles were actually in a very bad shape, and they have replaced it with new terracotta tiles. So, new mangalore tiles were added with a small insulation layer in between. And then the purlins and rafters were exposed so that the quality of the structure is visible very well from below, which is the idea of an art gallery. You need to see what it is. And here the building itself, the interior itself becomes like a art piece where you can see the structure completely, as you can see in the first picture. So, this redevelopment is actually only in one small part, and other parts will be redeveloped probably in due course. So, designing the exhibition space happened in this block, and the intention was to develop a spatial distribution for exhibition by only providing roofing, which is the character of the other blocks, but still the space should be highlighted. That was the idea. So, this is how the plan of the here you can see this is what was converted into art studios, Alembic museum, exhibition and display spaces. And here you can see the museum, multifunctional area, the studios and so on. So this is how it was done, and this is how the elevation looked like. You can see that the parts which were falling off, they did not chip and plaster and anything like that, but they added it as part of the mural, the cracks or whatever look as part of the murals, and this is the final outcome. We will now see, first this alembic is actually an industrial unit. We will now see another residential conversion. So we will take the example of the Chidambara Villas in Chettinad. So the Chidambara Villas is actually a 118-year-old heritage Chettiar house, and it has, as you can see, authentic Chettiar house characteristics, which is luxurious in lifestyle. Now the luxury is in details actually, and restoration was done by a group called a Sangam group, which actually manages this property too. So what they did was, the rooms were recreated and restored to the smallest and finest details, and at the same time the room has been subtly enhanced with all the luxuries and amenities to offer a very personalized experience, so that you get the best from both the worlds. The beauty of Chettinad is that the architecture is fantastic. The Chettiars were primarily traders. They moved away from Chettinad to various parts of the country and also various parts of the world. And so they had international exposure of things. For example, if you look at their mirrors, they would have Belgium mirrors. So they had the finest quality things in their house, apart from their own authentic style of architecture. Also, the Chettiars had a very unique cuisine. So the Chettiar cuisine is famous, called as Chettinad cuisine, all over the world, and Chidambara Villas offers that kind of cuisine whoever goes and stays there. Also, the Chettiars had a very different kind of play tools and things like that. All of that was incorporated in this house stay. So, the history of this building begins in 1884. So, this building was built around this year 1884, and then the Chettiar family, normally they lived abroad, the male members, they travelled abroad, and construction of the mansion here was done on 1 acre plot. So it actually took 7 years from 1897, when the construction started, to 1904 to complete this house. At that time, 120 years back, this cost approximately 7 lakhs. Now, as the Chettiars all travelled abroad, they had exposure to international materials. So, the wood here was brought from Burma. It was teak wood from Burma. They had marble tiles and granite from Italy. Chandeliers, lights, glass, mirrors were from Belgium. So, it's such a beautiful building, and its restoration took 3 years. And that is actually half the time of building a new house at that time, about a century back. So, why I am quoting this example in so much detail is, there are many such houses in Chettinad. I mean, for lack of certain things, they are just getting dilapidated. But this is one building which is withstanding its test of time, which has a beautiful courtyard, and this courtyard follows a reception and a lobby. It's called as the Valavu. So this courtyard is framed with rooms on either side. See, you can see the rooms on either sides. So these are actually rooms. So there are rooms on either sides of the courtyard, and the door of these rooms have beautiful and intricately carved images of gods and goddesses. And then actually each of the room belongs to one male member of the family. Okay, now nobody lives there, but during those days, each room was given to one male member. And after this courtyard, there is a lot of other, maybe sometimes there is one more courtyard. And this courtyard also gives very good lighting, natural lighting, ventilation. Also, it serves as a rainwater harvesting place and things like that. And you see, it was important that here I highlight how sustainable it was when it came to tapping the no, weather or climate elements. And the house could be as big as you could afford. And the Chidambara Villas is actually a very big house. So this is framed by pillars on a raised platform, and intricate carvings can be found everywhere, including the roof. Number of paintings are also there, and then the interiors are fantastic. And as you know, the Atangudi tile is very famous. You look at the flooring design here, that is a very traditional and typical Atangudi tile that is being used. So this building could have gone for demolition, but they chose to make it more like a resort. And now they have included a small swimming pool and things like that, because the houses on a 1 acre area. So they have enough space to include all this. And like this, there is potential in so many other buildings for adaptive reuse in India. Even in Chettinad, see here, there is another house I am showing, just a random house there. But then the house could over a period of time get dilapidated if it is not maintained. And not only that, there are many such structures which have great emotional, sentimental, historic value, which needs to be restored. Otherwise, we will lose a piece of history, and by demolishing it, what are you doing? You are only wasting the resource which is already there in this building. So, I leave you with this thought on adaptive architecture, and I will come up with another topic in the next class. Until then, thank you.